So, gentlemen, in this video we will be talking about what promises are, how they work, why they are needed, and what you can actually do with promises. But before we start, I remind you that subscribing to this channel, liking this video, and commenting help promote this kind of content. Also, don't forget to add me as a friend on VK, and in the description of this video, there is a link to Patreon where you can support the release of similar content. Now that we have covered the organization, let's get started with promises. In the last lesson, we talked about how asynchronicity works in JavaScript using callbacks as an example. And now let's do a small emulation of working with a server through asynchronicity and the callbacks approach. How will it look? Let's say, to start, I will display a message in console log. For example, request data. So, with this console log, I will be indicating that we are simulating an asynchronous request to the server. Next, we know how asynchronicity already works. We can invoke it using the setTimeout method, which comes from the browser API. And in the first setTimeout, we will act as if we are on the server and say that we are preparing some data. So here in the console, I will output preparing. It's as if the server is making a request to the database and receiving some data. And, for example, it will take 2 seconds to do this, just for clarity. Here, as if from the back end, we will receive a certain constant, which I will call backend data. For example, it will be an object that will have, well, some fields, such as server, AVS, and let's say port 2000. For example, the status working. In other words, any data. It doesn't really matter, just for clarity. At this stage, the server has prepared some data and it will take some time to return it to the client. We also emulate asynchronicity using setTimeout. So here I write inside setTimeout. I pass a callback function here. Let's assume this will also take 2 seconds. And here we will output the following message in the console: data received. And here we will output backend data, which we supposedly received from the server. But before that, let's perform a certain manipulation. Let's say we create a new key for the backend data object. For example, modified equals true, meaning we perform a certain manipulation. Now, if we look at the application in the browser, we will see the following result. First, we have request data. Then we have preparation data. And then we get a message that the data has been received. And here we get that object, incorrectly written as status working, where we get, in general, all the data that came to us as if from the database. And in fact, we implemented such sequential asynchronicity using callbacks, meaning we use the first callback where we describe the logic, then comes the next asynchronicity, we use another callback, and inside we implement our functionality. What is wrong with this approach? The problem is that we get quite a bit of nesting. That is, we have the first level of nesting when we pass a callback, and then we have a second level of nesting. If we had another synchronous operation, we would have another level of nesting. And so we get a large number of callbacks inside other callbacks. And accordingly, the more complex the manipulations, for example, if we need to make 3 requests to the server and then only combine all the data, we will have quite a lot of callbacks inside each other, and such code is quite difficult to maintain. So, promises came to solve this problem and simplify working with asynchronous operations. Therefore, I will comment out everything we had in the application, and now we will do the same thing, but using promises. How do promises work? For this, we just need to create a new variable, and you can name it anything you like. For example, I will call it P, and in JavaScript, there is a global class called promise. That is, we create an instance of the promise class. This is a class to the constructor of which we need to pass a callback, that is, a function. Let me write a function here for clarity, so if you are not yet used to arrow functions, it will be more obvious what is happening. This function takes 2 arguments as parameters. The first argument is called resolve. And the second parameter is called reject. Both of these parameters are also functions. And now we will talk about how to use them. Now we have received our callback function in the constructor of the promise class. And inside this callback, we need to write some asynchronous code. In fact, you can write synchronous code, but there is no point in doing so. Therefore, we usually write some asynchronous code here that we will execute. That is, in our case, we can also use, for example, set timeout. We pass a callback here because that is how the set timeout function works. So we already have console, log, request, data. So at this stage, we will emulate the server preparing some data. We will create a backend data object here for our project. We will pass the number of milliseconds to set timeout, which is 2000, and that's basically it. That is, we have some asynchronous code that we wrapped in a promise. Now, how do we work with this object, and how do we even access this data? Because we need to perform another asynchronous operation, and it's as if we need to send this data back to the client. This is exactly what the resolve function and the reject function are for. The resolve function is called when the asynchronous operation is completed, and it is completed successfully. In our case, we pass a callback function into set timeout, and this function is called when the synchronous operation is finished. So here, where we created the backend data object, we simply call the resolve function, and in this way, we tell our promise that it has completed its execution. And that's it. Now we have a variable p, which is actually a promise because we get it from the promise class. And each promise has a specific set of methods that we can use. We can refer to our promise and call a method on it called then. That is, it reads as when, promise when it is fulfilled. In the then method, we also pass a callback function. Let's say I am already using an arrow function here, but you can confidently write the word function here. And this callback will be invoked when some synchronous operation finishes. That is, the resolve method will be called. And here we can temporarily write, for instance, for example, console log promise resolved. Let's leave everything as it is, and if I refresh the page in the browser now, first we get console log request data, then we get the message preparing data, and only after that do we get the message console log promise resolved. That is, when some synchronous operation has passed, we immediately hit the then method, and that's really all there is to it. That is, we informed the promise that it was resolved, and the then method was called. Now let's add the functionality so that it works as before, using the example with callbacks. But for this, we need to use another synchronous operation, that is, make some modification to the date and then inform that the date has been received. And, in principle, we can do this directly inside then, but for this, we will need access to this backend data. So, to access this backend data, we can simply pass it to the resolve method. And this parameter will be received in the then method simply as, for example, an object data. We can verify this if we log it to the console. I will refresh the page. And as you can see, we are getting the data here as if it came from the database. Now let's repeat. The asynchronous operation, which essentially means writing the same thing again. For example, I will create a variable p2, which will be a new promise in which we will wrap another asynchronous operation. Here, I will use an arrow function. Here I will write resolve and reject. This is what the promise accepts. Next, we need to perform an asynchronous operation inside the promise. And here, let's fix the situation a little bit. So, we already have a data object that we need to modify. So we set data modified to true. After that, instead of logging backend data to the console, I will comment it out for now. Here, we will notify promise p2 that it has completed. So we call the resolve method here, simply passing the data object. Then, inside this promise, we can refer to p2, and when it is fulfilled, we will receive some data object. Let's call it client data here because we already have a data variable, and it's better not to reuse it. We will write data received in the console and log client data here. Now, if we save what we have and reload the page, look at the application. Request data, preparing data, and data received. That is, we get the same data here, plus there is a modified true flag. This means that we have correctly modified the data, but now the logic of our application works through a promise. And everything would be fine, but you might very unfairly ask me why we need these promises, because essentially we have the same level of nesting. We have the first callback, and we have the second callback where we write some logic, and essentially, promises didn't really help us much here. But there is one key point here that gives promises an advantage over callbacks. Certainly, we can create such nesting, but as you can see, it significantly coincides with what we would have done before. However, inside the then method, instead of creating another promise and referring to a new promise, we can simplify this situation. And instead of creating a new variable, we can return, say, a new promise from this then. Now we don't need this piece of code. That is, we receive some beta in then. Next, we return a new promise, and now, roughly speaking, we do not create new variables for promises, but after the then method, we can also call the then method because we are returning a promise here, and here we get the new data that we put in the resolve method. That is, here we can obtain client data and do the same thing, that is, log client data, to the console. Now I am removing the variable p2. We no longer need it, but if we refresh the page, you will see that the application works exactly the same. And essentially, this is the beauty of promises, because as you can see, we have only one level of nesting. In other words, we do not create callbacks within callbacks. We always stay within the same then method. Moreover, it reads much better than regular callbacks. That is, it is immediately clear that when the promise is fulfilled, we perform the next synchronous operation. When it completes, we then perform the manipulations we need. Plus, it's convenient that the P object can be passed anywhere. That is, for example, if you are using a module system, it can be passed between different modules, passed between functions, and simply use the then function to specify what needs to be done when the promise is fulfilled. Additionally, in the then method, we can also chain, meaning that this dot notation is called a chain, derived from the word chain, a series of links. We can also pass some modifications to the data. For example, here we can transform client data and say, for instance, let's have client data from the promise. This means we can modify these parameters and return this object from the then method. In the next then method, we will get a new data object, for example, and log it to the console. It is not necessary to return promises in then. You can return regular data and modify them sequentially. For instance, here I will write data modified. Date, if we save it, we will now get the date twice in the console. Yes, so initially we had the first date and then in the console, the modified second date, which has all the necessary fields. Basically, we can even remove this console log here. What else is good about promises? For example, when we work with some synchronous operations, errors can occur. That is, for example, the server did not respond, or we sent the wrong data and the server cannot understand what we want from it. If we use the callback approach, we have to add a bunch of ifs. For example, if the status is 404, then don't show the data, but display an error, and all of this is not very convenient. However, there is another special method in a promise that we can add practically anywhere, which is called catch. And in case there is some error, we will then enter the catch method with an error. Here, for example, we can output this error to the console using console.error. Let's write error here for better understanding and clarity. If we refresh the page now, we won't have any errors because we are working with timeouts and, as you can see, everything is displayed correctly. But suppose in the second timeout, something goes wrong, and instead of calling the resolve method, we call the reject method, indicating that we encountered an error. If we save, we return the page. Then we will see that we get a message in the console that we have an error. Here it says error. This is the line with error. And then there is the object that we pass to the reject method. In essence, by simply changing the resolve and reject methods, we can either indicate the success or failure of the promise, and then we can handle it accordingly. But I think it would definitely be more correct to move the catch method to the end. Let's see if this will save us from one error. Yes, now, as you can see, if we place the catch method at the end, we get only one error. That is, there are no modifications because we are not passing certain data here. Now I will return it all to resolve and leave it in this working state. In addition, there is another method in promises that we can use, which is called finally. This method will be called in any case, regardless of whether there was an error or success. This method will be called anyway. That is, we also pass a callback here, and here, for example, we can output a message finally to the console log. If we refresh the page, then regardless of whether there is an error or not, we will see a console log finally. Let's check. If I write reject here, then despite the error, we still get this console log. That's how it works. Now let me tell you about some more useful features in promises that will simplify working with asynchronous operations. For this, I will comment out all the code and write a small function called sleep that will add a certain delay, just a bit. So here I will create a function called sleep. This is a function that will take a parameter ms, which means milliseconds. And this function will definitely return a new promise to you, which takes a result parameter, an arrow function. And here we will add a delay using setTimeout, where we also pass a callback. Here we will call the resolve method, and directly in the timeout, we will pass the number of milliseconds. Let me break it down into several lines so you can see how this method actually works. So here I need a curly brace. That is, this is roughly how it looks. Essentially, we have a function that returns a promise and calls the resolve method after a certain number of milliseconds that we pass in. So how do we use this function now? Well, actually, it's very simple. We call it and say, for example, that we want to create a delay of 2 seconds. And then, after everything passes into that method, we will, for example, log after 2 seconds to the console. And we can do the same, for instance, for 3 seconds. If I save everything and refresh the page, the corresponding console logs appear after 2 seconds and 3 seconds. That is, as you can see, it is convenient to use, unlike setTimeout, because the code looks quite concise and convenient. And now, using the example of the sleep function, I want to show 2 more features in WebPromise. The global class promise has 2 more additional methods, the first of which is called all. In this method, we pass an array of promises. In our case, considering that the sleep function returns a promise, we can pass the sleep parameter here, for example, with a value of 2 seconds, and another sleep function with a value of 3 seconds. So we have an array of 2 promises. And the all method also returns a promise, meaning it has to then catch, and finally methods. And the promise that is returned in the all method will only resolve when all the promises in this array have completed. So let's look at the console log of all promises. Let's set it to 5 seconds here, just to make it clearly visible. If I refresh the page, let's assume that ideally nothing should happen in 2 seconds, and in 5 seconds a message saying all promises should appear, refreshing the page. Well, in principle, it is already clear that there was no message after 2 seconds. However, after 5 seconds, the message all promises appeared. That is, despite the fact that this promise was resolved, the promise all method waited for the other promises to resolve. And in this case, promises can be, for example, server requests when you need to wait for a set of data from different endpoints in order to combine them. This is very convenient and is actually often used. And similarly to the all method, promises have another method called raise. Let's discuss this one. I'll leave it. So in the raise method, we also pass an array of promises. That is, as you can see, here I am passing exactly the same parameters as in the all method, but here I will write raise promises. And what does the raise method do? Essentially, it takes a set of promises, and when the first promise resolves, meaning the one that completes the fastest, that promise will immediately be handled. If we look now, in 2 seconds raise promises will appear, and in 5 seconds all promises will appear. That is, it can also be useful in some cases when you need to determine which promise was resolved first. And that's really all there is to promises. Essentially, promises are a kind of wrapper around asynchronicity that simply adds convenience for writing code. Moreover, I will say that if you have watched the previous videos in this advanced JavaScript series, you already have enough knowledge to write your own class of promises, which will include all these interfaces. That is, in reality, promises are also built on callbacks and context, and you can do this yourself. I hope that promises are clearer to you now, and that this lesson was helpful. Well, I'll wrap it up here, and I'll see you in other videos.